All right, so let's get started. So this is Developing with Couchbase 1. I am Jasdeep Jaitla. I am a technical evangelist at Couchbase. There's my Twitter handle. I actually love using Twitter and communicate with lots of people over Twitter. So if you could, it's pretty easy to remember. It's scalable with a 3 instead of an E. I'd love more followers and conversations about Couchbase. Questions even. I've been dealing with questions on Twitter, which is interesting, having 140 characters to deal with complex questions. So what we're going to cover today is setting up your development environment, how Couchbase stores documents, an introduction to all the operations, or most of the operations in Couchbase. We're going to go through some document modeling. I'm going to go through an example. And during this, I'm going to be talking about agile development with Couchbase. So you probably have already seen some of this stuff in material, so some of it will be reiterating how Couchbase works. This is a very common architecture in Couchbase. And with modern applications that cross different platforms, you typically dedicate certain hardware for your web traffic, and then you dedicate certain hardware for your mobile traffic through APIs. Sometimes they scale differently, so you have different clusters for them. And what unifies them is Couchbase underneath. It is your caching and persistence layer. So this is a very typical replacement for the Memcache plus other database type architecture, whether that's SQL or other NoSQL databases. So I just wanted to make sure that we continue that conversation when we go through this kind of application. So downloading Couchbase is very easy. You go to the website. One of the first things you can do when you go to the beta, our new beta page is download for your development environment. Installing for Ubuntu and Red Hat is the standard command line install. Mac is just drag to applications. And Windows is set up, typical double-click setup. So getting Couchbase on your computer is under 5 minutes. It's very easy to do, and you can also we have AWS templates you can use for deploying on Amazon to make that even really quick too, if you don't want to do it yourself. We have smart client SDKs for nearly every language, or every popular language, I should say. There are a lot of niche languages. So, Java, .NET, PHP, Ruby, C, Python, and Go. I guess it wasn't popular today in our survey, but it's growing in popularity. A smart client is, our SDKs are smart clients, and you'll understand what that means in the next few slides. Getting the SDK is very simple. Setting it up is you go to Couchbase Develop, download the SDK, or if you're using Ruby or .NET, you have command line ways. You can download the gem, using your typical gem installs, or in .NET they have that new NuGet. It's very simple. Also on that website you'll see getting started and tutorials and links to our docs, and some pretty much immediate code samples. So this is a great page to land on and get started with. We're going to introduce some things here, and you can definitely learn more by going there. So talking about what a smart client is, it's useful to understand the topology of Couchbase. So the smart client, instead of going to a central location to find out where to get data or have a bottleneck in getting and setting data, the smart client actually hits the first server or a cluster of servers. If you configure it to try multiple servers, it gets back the list of nodes and their bucket capabilities and over REST. And from then on, it actually has a topology of where your data resides within the Couchbase cluster based on the keys. So the smart client will know to go directly to a particular node to get or set a key and value, or your document. It'll go directly to it, so it actually increases performance tremendously. Anytime that you add a node to the cluster, there is after the rebalance, it sends topology updates to the smart clients and maintains that. That way, it keeps track of where data goes, where it lives, and increases performance. So all our SDKs are smart clients. It's different than like using the original, like in the last year, some people used Memcache clients. This is one of the differences between using our SDK and migrating to our SDKs is what's recommended for people in other languages that we're using the Memcache clients instead. So this actually adds a lot of performance by using our SDKs. So we're going to go through the document basics. So in the traditional world, the old world, the way that we thought about data was in terms of these supersets of data, each for the particular type. And whenever you needed to put together an order, like this is an example of an order, you had to find all the data in the different tables and join them together into this single, into this single entity. And what Couchbase and NoSQL offer is an aggregated view of data, which makes it much faster to process, So instead of these heavy computations, as your data sets, your supersets increase in size, you have more and more computation required to generate this view of data. And instead, with Couchbase, the way we think about data is different. We think of it in a denormalized fashion instead of a normalized fashion. And so this is an example of between the two paradigms. Instead of having multiple tables, we're thinking of it in an aggregated form, in a denormalized fashion. What it enables is actually easier distribution, because distributing supersets is very difficult. Once you get into heavy replication and sharding in the traditional world, joins are very complex if they're possible at all. It depends on many variables. Everything gets very complex. And for application programmers, actually for developers, this view is very simple. My objects need data. I know how to store it. I know how to retrieve it. It makes it far less complex and more agile. Development speeds can actually increase tremendously. In larger organizations, making changes to schema is an organizational challenge as well, It's because you have to justify that schema change. It requires taking down the application and putting it back up after the migrations. And instead, developers have a little bit more control, and a lot of enterprise companies are looking at this to empower their developers to be able to make changes. And the other side is that not all schemas are uniform, there's a lot of unstructured data. When you're dealing with social data, there's a lot of variables that are new, actually, that are less structured, in which case adding new columns doesn't really make sense. You've got these variable columns, and that's where this sort of the flexibility of being able to work with JSON and have varying structures across your documents is very powerful and makes things a lot more efficient, actually, for development. And working with JSON is like working with external APIs. For people who are new to working this way or thinking about their object data this way, it's becoming more and more common. More and more people are exposed to consuming APIs. And working with Couchbase is very similar to that, actually. It's very similar. Everything has a unique key in Couchbase, So that is how you reference a document. And that is, like you see down there at the bottom is a set. We're setting a document and we're retrieving a document. It's based on that key, and every key is unique. So here's a representation of a user object in a non-language specific way, where we have an object here. We're representing it in JSON, and storing it in Couchbase. And then when we retrieve the JSON back out of Couchbase, we deserialize from JSON, and we have our user object back, right? So we're serializing and deserializing from JSON. So we're going to do a quick survey of all the operations. I think one of the most important things that I found, and I've been teaching many people from coming from SQL to NoSQL, I think one of the biggest adjustments is actually the speed of operations. With SQL, I've done over almost 2 decades worth of SQL myself, and the adjustment of this is actually one of the biggest hurdles I've found with people coming to Couchbase, is that in general, we feel like we need to hit the SQL as little as possible in our application. There's like this inherent knowledge that we're creating latency in our application if we go to SQL too much, right? So we have these massive queries. We try and get as much data in a single call as possible. And what's different with Couchbase is actually our get and set operations are so fast that having multiple gets for an operation, to get data is not uncommon, and actually will still beat, a lot of those SQL join queries. Yeah. So it's trivial to do gets and sets, right? It's not something to be afraid of. I think people feel like, oh, well, I have to have all my data in a single document because I only want to do one get. But gets are so inexpensive that actually you can use that to your advantage, right? And it's a big adjustment when getting used to working with this stuff I can hit my database with many gets, and it's going to be extremely performant still. It's not expensive. So our basic operations here, we're getting, we're setting, we're adding and replacing. Those have the caveat of throwing exceptions. In the case of add, if it exists already, it throws an exception. If it's replaced, if it doesn't exist, it throws an exception or an error. I mean, depending on the language, it's sometimes an exception, sometimes it's handled differently. In Java, it's based on what Java programmers expect, and for Ruby, it's what Ruby programmers expect. We have a compare and swap operation, which allows you to basically only change a document if it hasn't changed during the course of doing this operation. So there's a unique value. Every time you set an object in Couchbase or replace or add, it creates a unique CAS value, right? And that CAS value you can use to say, hey, I only want to change this document if it hasn't been changed. We also have atomic counters in Couchbase, and these have increment and decrement operations. These are within a given cluster, and you're going to hear about cross data center replication later, and I'll just talk briefly that within a given cluster, it is atomic, okay, within a cluster. When you do cross data center, you have to add some additional logic to your model if you're going to be using these as atomic counters, and there's actually very easy ways of dealing with that. When you have multiple data centers with the same counters, atomic counters. So these are actually useful for a lot of scenarios. In gaming, you can keep track of points this way. If you have like sort of virtual currency, you can keep track of that. These atomic operations. And there's actually, Jay Chris will, I think, maybe talk later about some patterns that you can use with this for generating keys. And if not, I can, in the lounge session later, I can show you some design patterns that use counters for keys, for key parts, which is actually quite interesting because you're within that cluster, like I said, you're guaranteed a unique value that you can use for your keys. Oh, well, I explained this already. So it's basically a positive integer, and yeah, I covered all this. So this is good for lots of different use cases. So I'm going to quickly go to an example. So on the right, I have a user class. For non-Rubyous, attribute accessor is just your automatic get set method creators. So it's a shortcut. The initialize there is basically taking a hash, and if it has that key in the or that instance variable, it will actually set that value. So And then save down at the bottom, I'm creating a connection. Now, in an actual application, I'd probably not put my connection there. I'd probably use it in a module if you're a Rubyist. But in order to keep everything on the same slide, save is basically setting, and my email is always going to be unique. So I'm going to use the email as the key, and I'm going to convert it to JSON. Right. So on the left, very simple Ruby code. I'm creating a new user and I'm saving it. Right. I'm sending it a hash of the values. That hash could have come from a form post, where your form submission or whatever. So very simple. Now I want to add a retrieval method, and there's different ways of doing this, but what I did was create a class method on user, find by email, and what I do is get the key, and if in Ruby we use nils a lot, but I get the document, and if the document was there, if the user exists, it gives me a user object back. If not, it sends back a nil. Right, very simple. So here I just added some more code. I want to find that same person by email, which happens to be me, and simple output of, hey, I found it, I didn't. And here so this is like how we work agilely with Couchbase. I want to add a few more instance variables, so I add a few more instance variables. In this case, a Facebook ID and token. And over there, I find the user, I add the Facebook ID and token, and save it back again. Right? So anytime you want to make changes, it's actually quite simple. And actually, I really love Ruby myself, and I find it extremely agile. I can simply add a few instance variables. I don't have to go create a SQL migration. I don't have to go, decide indexes and this and that. All this process of just adding a field, in multiple places, stored procedures if you're using those. So all that stuff, all that time, instead of that, I just have the time it took to write the instance variable name, right? Much faster. I can develop applications in half the time. So it's very significant. This flexibility is very powerful, and it's addictive actually. Yeah. When you get used to this paradigm, it's hard to go back, to be honest, to all that work just to add a column. It just seems ridiculous. Oh, hey, welcome. So. Actually, this is the CAS operation, but because of time, I'll defer this to the lounge, and I can talk about CAS operations in the lounge, right? Because that's actually a time-consuming topic. So document modeling. So the lounge, I think, is that's around 4:45. There are
a set of sessions in the lounge.
Oh yeah. So hit me or Sergey, our other Ruby guy, or anybody in the lounge. We could talk about CAS operations for you. So there's a few different paradigms for how you model, right? Whether you want to keep all your data for a particular object in one document, or whether you want to split it in multiple documents, right? This is a very common early question for people modeling in Couchbase, or creating their model with Couchbase. Do I put everything in one? With supersets, from SQL, people tend to want to have just everything in a single document. But there's a lot of advantages, actually, to splitting it out into multiple documents, right? And it really has to do with, bloating a document and changing the document, So I'm going to go through an example where we do both, right? A quick example where we do both. All right, where was I? Okay, so these are so your key value for your key for your document is like a primary key in SQL, right? It's unique, right? Documents are sharded based on that key. So that key value, which is a string, it gets hashed, and the result of that hash actually decides which node in your cluster it's on. It will live on. If you're creating it, it's where it will live. If you're getting it, it's where it does live, right? The lookup is extremely fast. Yeah. So there are different ways of doing these key values, and they're what I call creative keying. So there's a lot of different paradigms. You can use UUIDs, you can use date-based or time-based IDs, numeric IDs, and like I was saying, you can use a counter, atomic counter as part of your ID. You can, if you have like a, like for blog posts, if you have like the blog title as a ID, as long as that title is unique, which you can always check, that's a good ID. Human readable ones are preferred by some people, and then other people prefer, unique like the Twitter snowflake is a great ID example where you can generate them really quickly. That's a GitHub project. So there's a lot of different ways of dealing with that. Right? Can you explain a bucket? A bucket is very similar to having a database in SQL. Right? Like when you say create database, that's what a bucket is. But buckets don't have any size limits or anything. It's a conceptual container. Right? And Matt, unit of multi-tenancy, okay. Yeah, you could connect to a bucket. So if you have multiple applications, you might want to separate their key spaces by creating two buckets, one for each application. So a blog post object, right? Just similar to the user object, the example. Here I have nested the comments within the document. Like, so I have blog comments on this document. Right? And I've nested it in the document itself, in the blog post document itself, right? So this is one model. If you don't have a lot of comments, this could work great. But if you're an extremely popular blog where you get thousands of comments, you may not want to keep modifying the same document over and over, and it becomes a bloated situation, and actually can restrict certain other things when you want to have threaded comments, right? So this actually becomes a very complex document when you have threaded comments. So instead, I can't use those keys anymore. Here's another example where I've created a comment object. And my blog post object might have an array of these and as IDs or a counter. There's actually a few different really cool patterns you can do for this to have the multiple documents. But in this case, I have actually separate documents for each comment. Right? And there's good advantages to doing this in multiple documents. You don't necessarily want, if you don't need to, if you're only going to have a few comments, it may not make sense to create all the functionality and code to separate it all out. So these are some of the decisions that you make. It's like, how much data am I dealing with here? Is it more convenient and useful to have multiple documents? Right. So yeah, here's the example, the diagrammatic example of having a threaded with a separate, when you have separate comment objects, right, you could have threaded, so you can basically have nested comments underneath a comment object, right? Very simple. Okay. All right. Oh, there we go. And we still have time for Q&A. So his question was one of the reasons for separating out comments in this example would be avoid collisions. Not necessarily. I guess if you have lots of comments at the same time on that particular blog post, you're saying the original blog post document could have a collision. Yeah, that's true. It could. It could. I mean, things are really fast. If everyone literally hits submit on their comment at the same time, I guess there could be some contention. But that's not the only reason, right? If you have thousands of comments, you don't necessarily want to have an array of 1,000 items in your blog post, right? Well, not from a Couchbase standpoint, but mostly, yeah, from your own code, it makes your code a little bit more complex. I think keeping code small and short, I think this separation makes that a lot easier, more maintainable. But it wouldn't be hard to transition out of it, right? Because of this flexible schema, it would be very easy to change the paradigm if all of a sudden your blog became very popular, for instance. Right. Go ahead. Oh, if you had a single blog post object, if you wanted to change it to multiple documents, you don't need to do it with MapReduce. You would do it through your own application code transformation, where you just change it into, you pull the array, change it into IDs, and create the multiple documents. Sorry, yeah. I think you were first. Actually, generally speaking, a single connection per app server is actually fine. A shared connection on a single app server to Couchbase is usually sufficient. You can pool them, and you can talk to Matt about the situations where you might want to pool them. But that's too complex for a Q&A. Right. So I didn't go heavy into the architecture of Couchbase, but I can really quickly. We have replicas. Okay. Also, so a bucket is actually made up of 1024 virtual buckets underneath the hood, which your application doesn't see, but the smart client knows. So when we hash, we actually go into one of those. The key actually maps to one of those 1024 virtual buckets. Now those virtual buckets are evenly spread across your cluster. So if you have 2 nodes, there's 5, 12 each. And then if you have 10 nodes, you can do the math, right? We also have replicas underneath those vBuckets. We have replica vBuckets not on that node. So in a case of a node failure, you can fail it over, and it immediately starts using the replica. And those replicas are also memory optimized as well. Based on your memory configuration, it will keep everything in memory as well. So you have multiple replicas. They all have their own disk write queues and everything. So every time you set a key, the smart client knows also where the replicas are. So it sends it directly to you. Oh, so his question was, do writes wait for the replicas?
There's the new option observe.
Right. So basically, no, it doesn't wait. But if you want to make sure that it has persisted, right? There's an operation called observe where you can basically wait and find out, when it actually has been persisted to disk, right? And how many replicas it's been assigned to. Or just replication. Yeah.
Sometimes you're willing to deal with the same features having replication.
I'm going to make sure I understand the question. The replica went down.
Right to the master, the replication fails. Then the replica goes back up and the master fails.
Oh, you're talking about a very, very particular situation where 2 nodes are failing almost at the same time simultaneously?
You have a network problem where they
Oh, okay. That's a very complex problem, actually, that we should probably, just because I only have a few more minutes, why don't we talk about that after the session?
Sure.
Yeah, is that okay? That's a little longer. Yeah. But you have multiple replicas, so you're basically going to have to fail over to multiple nodes, and you're talking about a very particular problem. Right? Yeah. This is development 1, by the way. Yes, go ahead. And there is a multi-get operation if you want to get everything at once, right?
So you do a whole bunch of gets to get down to the nitty-gritty actually.
It really depends on how you model it. If there's referential IDs, you can actually, it depends on, there's a lot of variables there in how you design your documents, where you might be able to get to that, like in the blog post example, I could have a list of IDs for all the comment objects, and let's just say I want just the last 2, right? Then I know what to do. And if you use like a counter ID pattern using an atomic counter for the comments, I already know how many comments I have. It's very easy for me to just create the IDs for the last 2 and get them. So you don't always need, it just depends if you don't know in your traversal, like in a graph traversal, if you don't know what it is, then yes, you have to traverse with gets, right? Yes. Well, if you're using a numeric actually ID, it's always right, because it's going to be chronological by default, right? So you could do it that way. You are leading into what the 3rd session is about, is using views, where you can actually map and sort by date. So there's ways around it. You could use views for that, or you could really, if you use an incremental counter, it is chronological, But if you wanted to limit it by a certain date range, that's when we could talk about the secondary indexes and querying in the 3rd session. Yes?
So is your application supposed to know relationships across documents, sort of like a foreign key relationship, or is the cross-reference key embedded in the documents itself, that I am a comment from this blog?
Well, that's a good design, having bidirectional referential, integrity, but it's not the application. The model logic is in your application, right? It's in your business layer or your application layer. It doesn't live in Couchbase itself. So yes, you can create bidirectional, and it's actually recommended to create bidirectional referentials, for those kinds of models. I mean, this is actually a pretty simple example, and when you get into the real world of more complex examples, you still deal with these what I've described is sort of the same paradigm, but then now you're making multiple decisions for your object model of the same nature, right? Do I break this up into separate objects? Do I keep it in the same? It really depends on the complexity of your functionality.
And
But we can talk about it. Yeah.
how is user access control different compared to traditional databases? Who can see what?
You have to build that into your application logic. Yeah. So unlike, I guess, the very heavy, I guess there's two camps even of SQL. There's, the DBA style where everything, all the business logic is actually in these crazy long stored procedures. And if you want any modification, you have to go and, request it, right? And then there's another camp of SQL where actually, and I think .NET actually started moving a lot more towards this, is where all that is in your application, your business layer, right? In your classes and objects. And really you're just doing regular old CRUD, simple, select, insert, updates. Very simple in your stored procedures, right? Or you're generating your own queries on the fly, right? So there's those two camps, and Couchbase by default is the application layer.
You also support like foreign key referential function.
It's not SQL, so it's not a constraint. But it is, you can reference other documents as a JSON key value. Yeah, JSON key. I'm not talking about the document key, but the JSON key can say, well, for like a comment object, the blog post is this ID, right? But then you would do multiple gets to get it. You're not making a join. Oh, you mean I didn't do the referential?
Yeah.
Yeah. Well, actually, I actually did, because it's part of the ID. Oops. It's part of the ID.
Oh, I see.
So that's called creative keying. I didn't have to bother.
You didn't bother to put in a skill knowledge, literally an array of scalable hello 1, scalable hello.
I didn't need to. Yeah. So that's one of the as you get more and more familiar with keying and modeling, you actually realize there's a lot of shortcuts to things, because if you can create the key from the key, then it's actually quite easy. And
Is there a length limit for these?
is there?
Length limits? 250 bytes?
I think something. Yeah, 250 bytes. So I guess if you had a really, really, really long blog title,
You can only go 3 or 4 levels deep, right?
yeah, you'll have to have some mechanism for shortening it. But there's unlikely to have two of the exact same set of words made. But you can always, obviously, before you save, you're going to check whether it's, exists already. Yeah. Yes, sir. You can use your own mechanism, and there's multiple mechanisms. It really depends what kind of things you're modeling. So his question was, do we have our own ID generation mechanism in Couchbase? We have atomic incrementers, and decrementers, so you can use that actually as part of your ID, like user:1, user:2, and you're actually doing an increment, getting the value back. That's the counter pattern. You get the value back. Hey, the current value is 2. I use that in ID, right? Of course, you got to make sure in your application logic that you never decrement, right?
Generate the ID for the comment?
Yeah.
Is there a limit to the size of a single document?
About 20 megabytes, I think. 20 megabytes. There's a question way back there. Sorry.
Does your ID key, does your naming convention affect performance at all? So if you use
No. I mean, not performance in the sense that it affects memory, because we keep across the cluster, we keep all keys in memory. If they're all 255 bytes, you are increasing your memory consumption for keeping the key in memory. We keep all keys in memory across the cluster so we can immediately respond whether it exists or not, right? And that's an important part of our performance, right? It doesn't have to go find across all the nodes in your cluster, hey, does this key exist? We keep it in the, okay. I guess we got time for one more question. Sir. Oh, I don't remember that number. It's quite large. I think it's a big int, right?
It's a 64-bit.
64-bit unsigned int. It's quite large, yeah. I think we have more time. There was someone over there first. Oh, okay. And
So when you just said 20 megabytes per document, did you mean the attachments as well, or they're separate?
that's CouchDB. No, there are no attachments in Couchbase. Okay, we're going to be having demos all day too, and these are all our SDK and core developers doing these demos in the lounge. It's pretty much starting at about 1 to 4:30. We have actually some really, really cool demos that you guys should check out. All right, and that's it for 1. Stick around for 2. All right, thanks.